Good morning, everyone, and thank you for attending this session. So it's kind of interesting to be here let's see, this is Thursday, so the fourth day of the conference, and speak after so many great speakers, which I'm not a great speaker, so it's always humble. Kind of, I don't come from the future. I'm not working on HAL. I'm a bit boring, I'm afraid. So I live and work in Hartford, Connecticut. And you know what they say about Connecticut, right? People have no accent, so I'm here to prove that, of course. So as we mentioned, I'm the enterprise chief architect, which means a lot of chief and not a lot of architecture. But I'm going to talk today about really something that my co-writer who could not be here today, Murat Erder, he works at Deutsche Bank in London. And this is something we started about 12 years ago, when we were both at KPMG, both in New York. And it took us 12 years to actually get our ideas together and put them in a book. We were not very fast, clearly. So we actually published that book last year. So a lot of what you're going to hear today, hopefully, is an appetizer to kind of incent you to maybe read a book. But a lot of what on the book also is on the blog, so you can do that as well. What I'm trying to do is, number one, I have an accent, as you know. Number two, I speak way too fast. My mother can't even understand me in French, so you're not the only one. So if I lose you, if I speak too fast, please raise your hand, say something. The point of this is that to keep it very interactive, I don't want to be a talking head for 90 minutes. That would be awful. And so we're going to try to keep it interactive. And I have a couple of things in my presentation that's hopefully are going to get you to participate. We'll see. We'll see whether it works. And also to have fun. I really want us to have fun. We'll see whether that works or not. OK, so in terms of what I'm going to talk about is a brief, very brief history and context of why we got there and why some of us are worried about basically whether there's a need for architects, especially enterprise architects. OK? Sometimes I feel like a dinosaur. I'm going to talk about principles. We're going to start about principles. But what we're going to do is we're going to use a case study and animate the principles. Principles can be awfully dry. And by now, you had close to 4 days of presentation. So the last thing you want to do is listen to yet one more presentation. And if we actually have the time, I'd like to share some thoughts on modernizing monolithic systems. By the way, I don't know how many people were here in this room yesterday to talk about the presentation from 2 gentlemen from Argentina. And we ended up with a new name for monolithic, which is El Gordo, which I absolutely love, the big one. And then very quickly, we'll talk about why that works. OK, so this is not the all-encompassing. This is just my version of basically what's happening to our industry. OK, so the top part is the technology. And some of us are still old enough to remember mainframes. Okay? Actually, one thought of the mainframes is I wonder how many people actually work on the original mainframes. Okay? Thought they were going to last that long. I bet you not a lot. Okay? They're still around. Mainframes still around. COBOL still around. Kind of interesting. Okay? So that was 50s onwards. 50s for a long time. Then we had PCs. 1970s. Suddenly, we have computers that can fit on top of a table. Wow. This is great. You don't need 3 or 4 moving vans to move your computer. You can actually have PCs. Then about in the 80s, someone has said, well, wait a minute. I have some mainframes. I have some PCs, which I use most of the time to do games. Okay? Why can't we actually do the PCs to actually do something useful? We got into client server. Okay? Great idea. Okay? And things were very much the same. Then we had things like Smalltalk kind of emerged. Anybody actually programming Smalltalk? Yeah. It was great, right? Smalltalk was fantastic. Too bad it died, but it was fantastic. A lot of ideas haven't died, by the way. Then something funny called ARPANET. Okay, that network, very strange network, which someday migrated to a TCP/IP. And that gave birth to the World Wide Web, Internet. Can you imagine a world without Internet? Well, we spend a lot of time without Internet. I mean, I couldn't even find a way to home anymore, but that's what we had, okay? Then something funny happened, Java. Okay, first time, suddenly we had a concept of mobile software. Software could move. Interesting, okay? And then open source, things like SOAP, and then cloud. And someone could actually argue, I could argue, that cloud is very much back to the future. Okay? We need to be back to something that feels like a mainframe. Very large mainframe, but large mainframe. And then, of course, Hadoop. I didn't see any piece of data I didn't like, so put it in Hadoop. Okay? Amazon Web Services, and on and on and on. So the one thing that I see at the top is things are accelerating all the time and getting bigger and bigger. The bottom is our world. How do we develop an architect? Okay? And my view on that is we still write code. We do. Okay? And it's amazing to see that some people are awfully productive and some people are not. And that has nothing to do with methodology you use. You can be agile and non-productive, can be waterfall very productive. I've seen both. And we don't really know exactly why. I mean, we think we know, but we don't know why. I still remember fondly my first job interview. That's a long, long time ago. And it was in France at a company called Erder. And I wanted to program at the time. Okay? And I still remember what the manager said. We don't program anymore. We have code generators. Okay. I don't know where he is now, but they still don't have effective code generators. We had some attempts to actually make coding faster. Remember the model-driven development? Okay. Travelers actually had some, travelers went on the bandwagon of something called IEF at the time. How many people remember IEF, IEW? Oh boy. That became CoolGen and CAGen, that maybe, and we still have a lot of that in our systems. Problem model-driven development, they die, and then you're stuck with consequences. So something happened around this time, which was kind of interesting. People started talking about abstraction, the 7-layer model. The network could be more than just a bunch of wires and cans. You can actually talk about abstraction. And then John Zachman came around, and he has a framework. And one could argue this was kind of formal start of what we call enterprise architecture. Now we have all this framework, and we can be enterprise architects. And those were the happy days of enterprise architecture. We're sitting in our ivory towers and having fun and producing all these documents nobody read, but we didn't care because we were enterprise architects. And there's still a demand for that. If you see TOGAF 8 and 9, and I'm hoping I'm not insulting anybody here, but basically, and I mean, travelers will offer TOGAF classes. People actually get TOGAF certified. People come to see me and say, Pierre, are you okay with? I say, sure, get TOGAF certified. Give you two things, at least in my book, and that's a personal opinion. Don't throw anything at me. One, it gives you language to communicate, which is useful, and two, it gives you something nice to put on a resume. That's useful. However, there's a problem, and the problem is this. Starting around the 90s, okay, people started having a lot of great ideas. Object-oriented first, okay? Ivar Jacobson, use cases. I don't know if he really invented use cases, but we credit him with that. The SEI-CMM, the design patterns, the 4+1 model, which is really almost 4+2 now, because Philippe has now kind of realized he needs to include decisions. That's his. But all these things, UML, and then extreme programming. I don't know if you guys remember when Kent Beck was at the time working at Chrysler, came up with his book on extreme programming. That was in 1996, 20 years ago. So when we say agile and extreme programming is new, 20 years old, that's old news. Okay, so we've been living with agile for 20 years. Interesting. Okay, and then the Agile Manifesto, continuous delivery, SAFe, of course, which was basically, I think of SAFe as RUP version 2. Okay, but it's SAFe is SAFe, that's what it's called SAFe. And then perhaps, this is my little pun, perhaps continuous architecture. Now, if you look at the right side of this, what happens is there's a gap here between what I do, which is enterprise architecture, and what people do here, which is software development. And if you want to measure that gap, there are two ways, okay? The polite way, which is basically there is a litmus test. And if you take any agile project, and you take your youngest, more hyper developer on agile, ask yourself, because all these people make decisions. Decisions happen at all places in a project, okay? architects are not the only ones who make decisions, believe me. That we all, if you basically take your young guy, ask yourself how much you actually impact the decision that she makes or he makes. And you'll see the gap. That gap actually got totally spelled out for me a few months ago. I was basically in a meeting, okay, and my enterprise architect hat, okay, and one of the software engineers look at me and say, Pierre, do you know the difference between a terrorist and an enterprise architect? Have you heard that story before? Well, the difference is you can negotiate with a terrorist. Okay. Okay, so we have a problem. Okay, so some thoughts. Why do we even bother to architect? Well, if you look at this, that's a dancing house by Frank Gehry. And if you try to build this without architecting, not sure that this will work very well. Okay? Now, we can think it's beautiful or ugly, it doesn't matter, but the goal was they tried to build something. And by the way, talk about QARs, quality attribute requirements. They broke, because this is actually at a very busy intersection. So it was not a smart thing to be, but regardless, it's beautiful. Or at least I think it's beautiful. And if you look at this, could you really do this by doing a few sprints? Probably not. Okay? I don't think that will stand too well and it will last. So this leads us to, what do you think is architecture? And by the way, architecture is probably one of the words which seldom is used with some kind of qualifier. Solution architecture, enterprise architecture, application, network architecture, and on and on and on. You always have the urge of putting a qualifier. Okay? So I'm sure we all have definition of architecture. My definition of what's worth and Murat's definition is basically, at the end of the day, it's a bag full of tools. Okay? But like any tools, you need the experience to actually use them. You can't basically just have tools and not to know what to do with that. Okay? Try to use a chainsaw without knowing how to use it. It's not going to be a nice thing. Okay. The second thing you need, so the first one, I would almost state that anybody can do that. It's just a matter of time, experience. Second one is tougher. That's the ability to abstract at the correct level. Okay, again, back to what is the correct level, what is just enough. That's always a challenge. And to communicate the right decision. I happen to believe that architects are in the business of communication. Okay? There's at least 50% of what we need to do, which are social skills, not just technical skills. We don't always make decisions. I like to make decisions, but I don't always get to make decisions. My job is to facilitate decisions, to make sure that people make maybe the right decision, or at least make a sensible decision, and communicate it. And then plan ahead beyond the current project. Well, roughly we have two kinds of architects. Solution architects and enterprise architects at the end of the day. And the problem is solution architects tend to think of a project. Enterprise architects tend to think about a very long term. Well, the idea is to try to find a happy medium between the two. Okay? The interesting thing is what we do, the basic tenets of good architecture haven't really changed. I mean, we still basically very much kind of do the same thing. But what has changed? The scale. Okay? Remember the presentation yesterday from Jose Salvo about how many devices they're going to connect? That's mind-boggling. How do you architect that scale? We don't know. We don't really know how to communicate. So let's scale and also faster and faster and faster. People are impatient. They want us to work faster. What's tough? Okay? Now, what hasn't changed is organizational hurdles. I bet you, I wasn't there, but I bet you that when they built the Acropolis, okay, and by the way, we're not sure whether the Acropolis was built with real architects. We think that they were built by actually engineers, but we don't know. Nobody was there. But they had organizational hurdles. It hasn't changed. Any questions, anything so far? Simple? Okay. Keep on going. So basically, what do we call it? Larson effect. What do we call continuous architecture? And that's really about three things. A toolbox, it's not a methodology. We do not want it to be a methodology. I mean, that's the anti-pattern. No methodology. We want a toolbox. We want some principles because you want to anchor your toolbox somewhere. And more important, your context. And the whole idea is to improve by feedback, to to have this continuous loop. So we're going to see how that works. So, little analogy here, and this is inspired from a famous article called Cathedral and Bazaar by Mr. Raymond. I don't know how many of you have read that. If you haven't read it, read it. It's a good. So let's say we want to build a cathedral. We don't get to build cathedrals too often. And you get, let's say, you get an enterprise architect, an agile developer. What the enterprise architect is going to say is, where's the 5-year plan? Well, actually, for a cathedral, it probably is going to ask for a 50-year plan. But the agile developer is going to take a shovel and start digging. Okay? So you want somewhere to bridge that. Okay? You don't want a 50-year plan. You also want to don't start shoveling. Okay? And that's the whole idea of really making things testable, okay? Making things driven and respond to feedback. And also, people are not going to give you feedback if it takes you a year to respond to that feedback. So this is time concept, okay? And this is my little thing. So make enterprise architecture real. I like to be real. You know, it's not nice not to be virtual. And to also make solution architecture more sustainable. Okay. Yes, please. Fantastic.
You mentioned respond to feedback.
Yes.
And I feel that a majority of my time as an architect is digging and acquiring that feedback to see if this continuous system is meeting architecture, because lots of small decisions or decisions in various areas you need to interpret back to the architecture.
Excellent question. So the question is, how do you get feedback? And my answer to that, not the only answer, but my answer to that is we have trained, especially travelers, we have trained our users too well. We have trained our users to think that there is no phase 2. So unless you basically get all your requirements in phase 1, you're doomed. You will never come back to see you. So there's no point in giving feedback. So you really need to retrain your users. By the way, the word user, that's another comment. The word user is interesting because there are only 2 industries I know of that use users. Okay, one is the IT industry, the other one is narcotics. So I don't know if our goal is to actually get our people addicted to our system, maybe. But you're right, people don't give feedback on narcotics. So we really need to change. At the end of the day, that's why it's not technical at all. It's all social aspect. You really need to change the way people interact with you. It's hard. I mean, you're going to need to retrain them. We have one system that we briefly talk about at Travelers, which is a system we built for the new CEO. And because he was new, he didn't hesitate to give us feedback as a CEO as well. But it's unusual. It's very unusual. You really got to retrain your users. So I'm going to see a little bit of techniques to do that. OK. So the principles. Okay, and we're going to go more in details. But we have 6 principles. Now, why did we end up with 6? Don't ask me. It just sounded good. Okay? The first one is, and that's something that, we're going to talk more about that. Architect products, not projects. And that's tough. Now, how many people here work for a software company? So I don't have to explain to you the concept. You get it. Okay? You know what the product is. Nobody else does. Because I didn't know what it was until we actually started doing it. And the reason why, another litmus test, if you want to test whether you know what a product is or not, look around and see whether you have a job called a product manager. If you don't, then you don't understand products. And we'll talk more about that. Number 2 is, this is an SCI conference, so you guys are totally going to be on board with that one. Focus on quality attributes. This is pure SCI orthodoxy, of course. The third one is the concept of delayed decisions, okay, which is basically don't make decisions based on guesses. Because most of the time, or half the time, logically, you're going to guess wrong. And once you make a decision, it's hard to get out. Think of jumping out of a plane with a parachute. Well, it's hard to go back in. The fourth one is architect for change, okay? Leverage the power small, but also remember also something that this is now Back to the Future, 1970s, loose coupling. Okay, very powerful concept. We all understand it. How many people actually practice it? Not too many. Okay. The fifth one, if this is not, we're not just worried agile here, okay? And actually, I would say that what I'm talking about doesn't really even apply only to agile. It also works with iterative, it also works with waterfall. The idea here is you take into account the whole development, including production. Okay, how many people were actually attended Ian Wood's talk yesterday? That was a great talk. I was actually torn because Paul Langdon, who also was a traveler, was at the same time doing a lab on IoT, which I also wanted to attend. And I haven't quite mastered the power of cloning myself yet. But I actually wanted to be involved. But the production thing was absolutely remarkable. It showed me how little we know about production. And that's why we really need to architect down the whole thing. If not, the value of a system which doesn't go into production, zero. So your system are only going to have some value if you actually can put them in production and keep them there. It's not enough to get to production. You actually have to keep them there. Okay? And then, of course, no talk on agile architecture, continuous architecture is complete without mentioning Conway law, of course. I wonder when Mel Conway actually, and I don't think, if this was something he said at a conference back in the 70s, and I don't think he ever realized, poor guy, but he's flipping his grave, he passed away, and he must be flipping his grave. how often we actually mention his law, and no, I will not do a reverse Conway maneuver today. I'm not going to do that. So let's dive into that. So this is the first one, product, okay? And product has two interesting aspects. One is it forces you to think outside in as opposed to inside out. If you're going to manage projects and architect projects, okay, project managers are worried about deadlines, okay? And they are worried about budget. That's what we worry about. And they want to make their deadlines. Now, little story on that. Nobody will ever remember that you actually develop and actually delivered something on time if the thing doesn't do what they want. They will remember the fact it doesn't do what they want. So time has a very, time of delivery can be very, very misleading. However, what's important is if you actually manage what you do as a product, what's important is satisfaction of your stakeholders. People actually want to buy your product. You got to think like a software company. It's very, very important. Okay. Projects are also often part of a product. So you may as well try to architect a product. Also, a product has a longer life cycle than a project. So you get the feeling of now I'm architecting something that's going to last longer. Much better. Okay? And of course, this gets us to think about product management. Okay? How do we do product management? So, little slide on product management. No need to read that thing. It's way too long. But really, product management starts a product manager. You got to have a job in IT because so we started putting product manager in IT at Travelers. We had product managers before. They work in a business. We're an insurance company with our products in insurance. So the first time that actually went to the head of HR and I say, hey, her name is Vivian. I say, Vivian, I want to hire that guy as a product manager. She said, sure. Okay, we don't have a job description. No problem. Just give me the name of someone who does the same job. I did. She came back running in my office. She said, Pierre, you give me the name of someone who works with a business. I say, yeah, and your point will be? So we solved that one. But that to us was the big hurdle. So the whole idea of treat your product managers as a first-class citizen, very important. It's not a technical job. It is not a technical job. Okay, don't try to make the tech lead the project manager or the architect the project manager. That doesn't work. You want someone who actually manages the product, which means managing the life cycle. Okay, that's a job by itself. The fill or kill, actually, Murat got that one. This is something they do at Deutsche Bank, which works very well. Okay, they take a look at products every quarter, I think. Could be monthly, it doesn't matter. And you do usual consulting thing, the two-dimension thing, and you look at the demand and whether the thing is tactical or strategic. And the stuff that people want, you're going to fill, you're going to put more money. The stuff that people don't use, don't put more money, kill it. Okay? Again, that's what a software company will do. If something doesn't sell, what are you going to spend more money on? Okay? Unless there is an ultimate reason to do it. And get the commercials right. treat your products like basically they are something you sell. Even if you have a captive audience, like travelers, when my customers don't get to buy outside, maybe one day they will, but right now they don't, okay, we still treat them as customers. It's a whole concept, okay? And the architects need to be very aware of that. It's kind of changing the job a little bit. Any questions on this? Did I lose anybody? Yes?
Are you using strategies for communicating the value of the role of the product owner on teams?
So that's very much a work in progress. So the first thing total disclosure. So we worked to get to that point at Travelers. We worked with a company called Pivotal, which made the news today. But so Pivotal Labs, and Pivotal Labs, and just one company to work with. We also work with Rally. I mean, same. But we found Pivotal Labs very good at really forcing us to have a discipline of the product concept. Okay, we did one project, which was a project we did for CEO. We didn't have a project manager. We had a product manager. Okay, we didn't have QA. The whole QA was done, which is totally heresy. I mean, at Travelers, we have big QA organization. What do you mean you don't have project managers? What do you mean you don't have QA? Are you crazy? I think I'm crazy, but that's okay. But the whole point was you have to change the culture totally. So it's not going to be an evolution. It's going to be basically a gap. So it's almost continuous architecture is just part of that evolution. But that's changing. The world is changing. No matter what, whether we are part of a change or we're not part of a change. That's simple. I mean, we don't want to be left behind. Make sense? Okay, so now, the exercise. Okay, so I promise that I'm not just going to make it out a talk. We're going to try to kind of think a little bit about. So I will use, for this, what I'm going to do is basically to think of a case study. And a case study is basically a large corporation. I mean, think an insurance company, that helps. Because that just got a request to do a new mobile system. And they have never done a mobile system before. Oops. Okay? Well, they have done a lot of web-based systems, but no mobile system. So what can they do? They've got a problem. Okay? And a system is about, by the way, mobile shopping. It's just about you have some prospects that want to get quotes. Okay? So insurance quotes, for example. The thing is, what people are thinking is usually you get an insurance quote when you basically shop for a car. So on your Saturday afternoon, you are car dealers. And usually don't shop for a car with your laptop under your arm. Most people don't. You usually have your iPhone on your belt. So you basically want to get a quote because you want to know if I buy this car, how much basically is it going to cost me? If I buy that car, how much is it going to cost me? Simple. So I use a couple of icons to help for the exercise. Okay, so Rubik's Cube is the challenge, how to get started. Okay, and a couple of tips. Okay, in this case, so let's try to start small. I know. Orthodoxy is usually every time we start a new project, we basically try to get a new architecture, a new everything. Well, let's think differently. Let's try to refactor instead. Okay, can we actually do? And is there an existing system somewhere that will provide similar capabilities? What do you guys think? Again, what's on the right is what I call usually a architecture, which is, any architecture on PowerPoint tends to be a little bit of marketing architecture. So, what they did was they drew on a piece of paper, PowerPoint in this case. They have a website because they know enough to know that they're not going to be able to write a native app because they don't know what device your customer is going to use, right? They could be using an iPhone. It could be using Android. You don't know. So to get started, a mobile website is probably safer. Okay, and then you can get ambitious. You can start a hybrid app. You're going to have some integration services, some business services, and of course, this is assume an insurance company, so a lot of legacy systems. We call that a backend. El Gordo again. Okay, so and some security because we are. So, what do you think they do? No guess? Nobody wants to guess? Okay. going to be hard. We're not having an interactive session yet. Okay, we will have an interactive. Okay, so here's the answer. Okay, they go around and say, you know what? We actually built a web-based system, which is, again, not very useful because people don't shop for insurance at their desk usually, or don't shop for insurance in their house. But they built actually a web-based system some time ago, and they're actually managing this as a product. Okay, so they go and see the product manager and say, hey, would it be cool if actually we merge the two efforts? What an idea. Okay, which is basically now you add a mobile website to the existing website. So look at what happened. Now the product is really a coding system. Okay, and in product lingo, I'm definitely not a product expert, but a long time ago actually I read a book on product management. And in product lingo, you have a platform product and derivative products, which is what you build on the platform. So the platform product is basically the coding system. The derivative products is basically the web interface and the mobile interface, and on and on. This allows them to actually minimize, basically, the rework. Yesterday, so it's actually interesting. Yesterday, we were talking a little bit about reuse. And when we think about reuse, we tend to think about code reuse. But reuse has many, many aspects. You can actually reuse designs. You can reuse architecture. You can reuse concepts, which I will almost suggest it's much more effective than reusing code. So, and of course, what you're going to do is consolidate the product roadmap. Okay, very important, and consolidate requirements. Any questions on that? Simple, right? Yes, no? Good.
It's only simple if the requirements that team was using have alignment with what you're trying to do.
Exactly, exactly. Or it's also simple if the definition of a product initially can encompass what you're trying to do. Absolutely. Every example is simplified. Because this is, at the end of the day, this is an hour and a half talk. This is not a 3 days talk. We tried 3 days, that would be. Okay, so that's the number one. This one is going to feel familiar. How many people actually are used to this strange thing here? How many people know what that is? Good. It's called utility tree. Actually, the tool I use to do utility trees is, I'm a mind map fan, so I use a mind map tool, of course. And utility tree, I'm going to see more of that. It's a classic SEI tool. Actually, if you have been trained on ATAM, I'm sure. How many people actually have been trained on ATAM in this? Yeah, good. So if you've been trained on ATAM, it's actually a very effective way to document quality attributes. Okay. So a little bit of SEI. This is not a class on requirements, absolutely not. The SEI theory here. So two kinds of requirements, okay? The functional and the non-functional. I try not to talk about non-functional because it's kind of an oxymoron, non-functional. So I tend to talk about QARs, quality attribute requirements. And yes, in theory, non-functional include QARs plus constraints. In practice, I just use QR for both. So assume constraints are just part of. Hopefully they won't wait for me at the door. And now, what happens with QRs is funny. Okay, QRs are usually very poorly documented. Those are actually real-life examples. Okay, I've seen them. The system must operate 24/7. That means no downtime whatsoever, every day of the year. Really? When do I service the system? The system must be extremely user-friendly. Not only user-friendly, but you want extremely user-friendly. What does that mean, right? How do you measure that? I don't know. Okay, and my favorite, the system will be very fast. Not just fast, very fast. Okay. Yet, the thing that people realize or don't realize, okay, they drive your designs, whether you like it or not. Your QARs are going to drive your design. So you have poorly documented requirements that drive your design. What do you think the result is going to be? Okay, and again, SEI, pure SEI orthodoxy, okay? Think of functional requirements as what the system must do, while QARs as how you do it. And of course, we are very concerned about how to do it, okay? So, Philip's story. Now, I heard that story. I actually read that story a long time ago. I couldn't find the darn story. The story goes like this. 1992, Philippe was working on the Canadian traffic air control system. And they had a requirement that from the time the plane entered their air zone to the time you actually display, the response time was 125 milliseconds. That was 1992, right? The time, just the transmission time was 4 seconds. So how do you do that? And the poor guys were torturing themselves. It was really bad, really, really bad. Until one day, Philippe was jogging around Vancouver. And he's a pilot. And he saw a radar evolving. And I didn't know that until he told me. There are two kinds of radar, primary, secondary. Primary is you get the echo. Secondary, you identify the plane. Those things revolve in 15 to 20 seconds. Now, if the radar evolves in 15 to 20 seconds, why does it matter that I can process the whole signal in 125 milliseconds? So, kind of big light bulb going on Philippe's head. So he went to see the user who happened to speak French. Philippe speaks French, well, that helped. And the guy said, no, I never said that. I didn't say that. What I said is, once you get the signal on your display, it should take you 125 milliseconds to just process on the display. Yeah, right. Thank you. 3 months down the drain. But the story, and it's interesting because I heard that story a few times and I couldn't find it. No, I really scanned so many articles, couldn't find it. Eventually what I did, I just reached out to Philippe. I said, okay, tell me that story. That's how I got it. So it's on my blog, it's in the book now. But the whole point is talk to people. Don't assume, never assume. Okay? Because if you assume, bad things are going to happen. And of course, designing of QRs limit the number of candidate architectures. We know that, that's again. Okay? So far, so good. With so long QRs, good. Oh, sorry. I clicked too. Please.
How does the QRs limit the candidate?
Oh, because the best way I can explain it is basically, so if you have a set of functional requirements, theoretically any architecture design will satisfy. You can have a blob of software. And so long it does what you want to do, it's fine. Just doesn't define how to do it. Now, if you start applying your constraints and say, I need a response time of 2 seconds, for example, your number of possibilities shrinks. We're actually going to see that on the next slide, if you bear with me a second. So this is where the QRs, so this is a full, and again, for people who are trained on ATAM, that's easy to understand. So the way you draw one of those utility trees is you put a system name at the center, okay? And you put your QRs as the leaves of the tree, okay? And you try to basically, I like to organize them in priority order. Don't have to, but it's nice. And then the next thing, you basically refine them. Because if you think about it, okay, configurability could mean many things to many people. Okay? In this case, I'm concerned about 2 refinements. One is ability to change the UI layout. And the second one is ability to change business rules. That's what I'm worried about. Okay? Now, that still doesn't mean much. So that's why we use concept of scenarios. And I've kind of cut down a little bit the definition because the full ATAM scenario is kind of long. So I just stick to stimulus, response, and measurement because that's all I care about. The idea is you really you define one example of use of the QAR. And that eventually is going to drive and define your architecture design. It's kind of laser focus on that. Example. In this case, let's say that we are still doing our little bit of the mobile shopping system, and we're worried about performance. Because we know that basically people are going to use their iPhones or their device, I use an iPhone. And one thing happens, people have no patience anymore, okay? A 1 second response time is a long time. Now think about that. The first system I ever worked on, they were actually interactive. 1 second would have been nirvana. Like, 1 second, you can do 1 second? Try 10. 1 second on an iPhone is an eternity. People don't wait. Close, next, okay? Which in my world means close travelers go to progressive. Not a good thing. We don't like that. So they are worried about performance and especially latency. So what do you think they do next? So now let's play that game. So what would you, if you are part of a project team and that's all you know, what is your next move? No? No move?
Write an app.
Yes.
For them.
Yes. Thank you. That's exactly prototype. Write an app. Okay? That's why, so this is I'm going to say another thing. How many people in this room are architects? Everyone, right? Almost. Of those, how many still code? Yeah. This is an interesting phenomenon. Okay? We had, remember my timeline? At some point, you could not be an architect with coding. So architect basically had to do with coding. Technical job. That at some point, the two split apart. It's almost like if you're an architect, you should not know how to code. That's absolutely. And now we're seeing that they're coming together again. So a friend of mine who works at Pureur as well, Andrew Clay-Schaffer, is fond of saying the best way to settle an argument with two architects, okay, over a fist fight, is basically to write some code, because you settle the argument. Okay, code doesn't lie. No, it's kind of interesting. So in this case, what they do is they say, okay, so we have a prototype, okay, very limited functionality, one field, very simple form. That's not the point. The point is to look at the round trip and to see if you can even make your SLAs. Because if you can't, it's time to stop. Okay, so the power of prototype, but the idea is focusing, you see how focusing on QARs forces you to think about all the layers of the architecture and how the design reacts. Because if you didn't make basically your QAR, then you have to change the design. Okay, and they do that in a week, which is probably a bit long, but and you get the answer quickly. So far, so good? You buying that? Good. Number 3, the delaying decisions. Okay, it's an interesting principle, and the principle is really that you don't really want to make decisions based on guesses, and because most of the time, 50% of the time, logically, you're going to be wrong with guesses. So you're going to make a wrong decision and bad things are going to happen. So you have to delay your decisions until you actually know the facts. It's hard, really hard. Now, why is that? So if we think about the requirements, functional, non-functional, doesn't matter. How many people actually, when they collect requirements in this room, can actually talk to the real stakeholders, people who are actually going to use the system? Wow, you guys are lucky. You need to tell me how you do that. Travelers, most of the time, we end up talking to proxies. And the problem with proxies is that they tell you what they think the user system should do. Well, that may not be. So you get this layer of basically indetermination. The second thing that happens is that human brain, we'll have one, okay? The human brain works very well when you ask people to give you feedback on something. When you give them a blank piece of paper, it doesn't work that well, okay? And because of that, but people are polite. They don't want to tell you, well, I can't tell you what. So I give you something. The problem is something that may not be what you're looking for, but you don't know that. That's why I became more and more convinced of this kind of the minimum viable product, which is the idea is you put something in front of your stakeholder very quickly, and I think could be totally wrong, okay? But it doesn't matter, because what you're going to do is this is to prime the pump. Solicit feedback, and here's the trick. You need to react very quickly. If you let too much time spend between the time they give you feedback and you deliver that feedback, people are not going to play the game. I know it works because we work on this on a project with our CEO, and he wanted something very, very special. And I remember the first meeting we had with him, which was amazing what we actually got in front of him. And one of us asked him what he wanted. His answer was, I don't know. This was, I need to give you a bit more detail. This was about an internal social media system. And he said, well, I want something that looks like Twitter and Slack. Okay. So based on that, we're able actually to build a prototype, an MVP, sorry, and basically deliver something which it could react and we could adjust quickly. So that's, you really need to create really a feedback loop with your users. And once your users, you need to get them out of the thinking that all you have is phase 1, because there is no phase 2. You need to really think. And the idea is think quickly. Okay, and then that gets into my two, before that, modifiability. Okay, beware of that, because QAR sometimes I want modifiability. What do you mean? Well, modifiability could mean many, many things. So that could also get you in trouble. In order to do an MVP, okay, you need an MVA, minimum viable architecture. Don't do too much architecture. Just do enough. Okay? Avoid, this is my acronym, the big architecture up front, the BARF. Tell people don't BARF. That's an easy one. Good with that? By the way, I didn't explain that little thing up there. I should. This is also Murat idea. Murat has a PhD in statistics, and this is known as simulated annealing. Okay, this is a technique very, very quickly, because that will exhaust my knowledge very quickly. This is a technique to actually clean an image. A probabilistic it's used by many, many things, but one of them, and what you do a lot of iterations. At each iteration, you actually look at the pixel, and you adjust the pixel based on certain characteristics of neighbors. Interesting. Turns out that something funny happened. If you rush too fast into making decisions or fixing the value, you're going to break the image. Which is why they call that simulated annealing, because it's the same thing as cooling down a piece of metal. If you cool down a piece of metal too fast, it breaks. Same thing. So think of that in terms of don't resist the urge of making decisions too fast. Very important. Cool? Okay. Now, okay, so now our team basically got a chief architect, kind of descending on them, and say, hey guys, okay, I'm worried about you. Okay, why aren't you using caching? No, we have all these great caching products. Okay, why aren't you using caching? And why aren't you using a rules engine? We love rules engine in insurance. We never seen a rules engine we didn't like, believe me. I mean, I've done some of them, so I'm guilty. So, what would you do? Any idea? Would you go for caching? Would you go for rules engine? Just take a guess. No wrong answers. Sorry? Well, you already did. You did build a prototype. That's done. And remember what the prototype told you is basically that your performance is good enough for the time being. So don't do caching yet. You may end up doing caching. Now, you may want to think about, maybe one day I'm going to have to do caching. So again, the idea, isolate the part where you may do caching. That's a good technique. Rules engine, I don't like rules engine. Even if I say that I really don't like them, because they tend to hijack the architecture. And this has to do, again, with an old principle, the principle of avoid tight coupling. Okay? If you could keep the rules engine to just affect one tier of the architecture, that would not be a bad thing. But the reality is that most people don't. And actually, what's on the right is something that actually happened to us. You know, we love rules. So the rules engine started in the back end, underwriting rules, and then found its way to mid-tier. And then before we knew it, we're generating UI as a rules engine. Okay, now you have a great title. I mean, now, rules engine came from IBM. IBM loved us. They own us. You're stuck. Exactly. You're stuck. So think about that. If you absolutely must have a rules engine, if you absolutely tell me you must have a rules engine, I would suggest the thing you use is put in a cloud. That will force you to limit the interaction, believe me. So that's a technique. But loose coupling is so important. If you remember one thing out of this talk, avoid tight coupling. I mean, and you'll be much happier. Okay. 4, okay, the power small. That's really not only power small. It's also really, this is where the tight coupling and the loose coupling. So now, I don't know about you, but when I think about coupling, I tend to think about coupling between software components. That's true, except coupling happens in all kinds of strange places. Okay? It may happen in databases. Okay? A database is a very, very, very tight coupling engine. Okay? Once you have this big mobile database that everybody has to basically use, it takes time. It's not easy. Okay? You have a case of tight coupling. Roast engine, we just saw that. Okay? A little thing I like, I think it's called Postle's law, the robustness principle. Okay? That also will keep basically your designs happy. Okay? Assume that basically, so be very, very conservative in the messages you send. So if you have an interface and you send something, be conservative, okay? But be liberal in what you receive, okay? Basically assume that people maybe are not as careful as you are. And again, you'll be much happier, okay? Because people are going to send you things that you don't expect. So if you get that kind of philosophy in your designs, you're going to find out your design is much more robust, okay? And when you want to change them, because this is all about changing, right? This is basically, the idea is what changes can happen, much easier. Not easy, but easier. Change is never easy, by the way. Okay? So, microservices. I had to have a slide on microservices. This is, of course, the big trend of. So, microservices, and actually, it's my kitten slide. How many people, of course, I think of microservices as kittens because basically, microservices are independent. They're cute, okay, they're kittens. They're independent, and they own their own data. Try to take food away from a kitten, okay? That's a very dangerous thing to do. How many people use microservices here? How many people think they use microservices? The reason why I'm asking is I came across a research note from Gartner that I actually like a lot that really contrast, they call it a new term, that's what basically research houses do. And because microservices are tough. If you really want real microservices, okay, that means you're probably not going to want any reuse. Yeah? And an anti-pattern of microservices, you do not publish your APIs. Oops. Okay? So clearly, what's going to happen with microservices is that it's not for everyone. I know they are cool. I know everybody wants to be a microservices. So what Gartner has coined is the term mini services, which means you want to slim down your services because they're too big. I mean, services tend to be a little, especially if you use SOA, they tend to be bloated. So you want to slim them down because we understand power small. I mean, small is good, okay? But you really want to make sure that sometimes too much is too much. Okay, Chris, you want to say a few words about, because we actually work on a system where, Chris and I work on a system where we have some microservices, a lot of mini services.
Yeah, so basically what we did is we have a Node backend running against a Mongo database. And the way we designed it is each service that we have in that collection connects directly to one and only one collection in the database. So if we ever wanted to split that out, we could actually make those into microservices. But right now they're interrelated, and we don't have a need kind of to go further than that because we don't have any outside consumers looking for those capabilities. So we designed it in a way that we could split those out later if we ever had a use for that. But in the short term, we're kind of in a co-located database that's sort of mini and can be developed by our internal development team.
Thank you. Thank you. So Chris touched on something very important. Your data architects are going to hate microservices if you tell them, in a way, I do not use that word lightly, they're going to hate it if you tell them that the microservices should have their own database. This is like, burn a stick immediately. People who pitchforks outside your office, bad. Also, no reuse. Well, if I go to the trial CIOs and tell them, we're really going to have a no reuse as our design philosophy, they're going to throw me out for the window. Because at their level, reuse is a good thing. Well, it's not always a good thing. It depends what you reuse. Again, back to my little thought. If you really try to reuse the design architecture, I think it's goodness. Reusing code, not so much. Okay? So, but bottom line is microservices are not for everyone. And there is, by the way, nothing wrong with not doing microservices. There is something wrong about definitely implemented on purpose tight coupling. That's wrong. But microservices, yes, if you can do that. A couple of comments, they are not just a REST API, we know that. I mean, but some people still believe, if you have a REST API, woohoo, have microservice. No. They are basically not about code base size. I know they're called macro, but you can have a macro service which is actually big. Okay, Bezos, of course, Amazon, and I went to Amazon about a year ago, and they explained to me the whole thing. It's really the two pizza team. That's a very subjective thing, depending how much people eat and how big a pizza is. Right? But one thing to keep in mind, what they mean by that is they feed the whole team. So not only developers, but DBAs, operations, so on and so forth. So that gives you, suddenly it's a crowd. So you're going to feed them with two pizzas. So it's kind of small. Right? What I like better is pain. Okay? The pain, that's a good indicator of whether a microservice gets, it's not a microservice. If people have pain communicating, okay, you probably don't have microservices. Okay? Because if your microservices are very independent of each other, you should not have any pain communicating. So if you listen in your weekly meetings or your weekly iteration meetings and you hear pain, probably a good indicator. Okay? So they are all about velocity. This is about speed. Okay? The whole idea is we want continuous everything. Okay? And you want speed. Okay? In order to get speed, there's only one way, small batches. Microservices are ideal. They are not the only thing. But keep in mind, everything in life is a trade-off. You're going to get velocity, you're going to get also a lot of complexity. Okay? If you want to do microservices and not change the way you deliver software, you're going to have problems, big problems. Because you're going to have a lot more kittens to deal with. And those kittens can get fairly nasty. Functional decomp, that kind of brings back good memories, right? We did functional decomp about 30 years ago at this point. Okay, nowadays we talk more about domain-driven design. Now I know it's boundaries and so on, but it's kind of old concept coming back. Okay, robustness, robustness is a good thing, especially if you put it in production. Easier said than done, but there are techniques to that. And of course, graceful degradation, which is also good. But you can at least do all of them with mini services. You don't have to have basically microservices. Now, the big question is that basically SOA under a different name? I don't think so, personally. But that's personal opinion. Okay? I think that my view of SOA was always it tended to be based on a bus. You had a smart bus and a bunch of fairly dumb services, relatively dumb. Okay? And vendors love that because it can sell you an ESB. Remember all ESBs, TIPCO, and all the rest? Okay? And this is all the whole concept of orchestration. Think of an orchestra, right? So the orchestra, the conductor has a problem, the orchestra stops. Although every player knows how to play, they can't really play without the conductor basically directing. Now think about choreography. Think of ballet, your favorite ballet, right? Swan Lake. Okay, one dancer has a problem. Well, unless it's the ballerina, head ballerina could have a problem, but they can still continue dancing. And I think it's the whole concept of microservices. Now, it's also going to depend on something we're going to talk about in a minute, which is your organization. Travelers tend to be very much a command and control organization. Okay? So, again, good luck always principle. The design you're going to end up with will probably be much more of the orchestration type than the choreography. You got to distribute, in order to do microservices, you got to distribute the smarts to your microservices. Again, not a technology issue, mainly an organization issue. Remember my Greek story, organization hurdles? We're still there. Any comments on that? Somebody must disagree with that. Yes?
So my understanding is that, the microservices bring simplicity, and then you talk about robustness and graceful degradation, which kind of say simplicity. But then you are saying they increase complexity.
Yes. Very simple. You got a lot more of them. Okay? The number of units you're going to deal with is very large. Okay? Now, I don't know if you know, so a year ago, when I went to Amazon, they mentioned to me, the CIO of Amazon got comment. At the time, they were doing a deployment. They were deploying every 7 seconds, I believe. Okay? Now, the latest I've read, they're actually deploying every second. We're going to get to a point. They're going to get to a point where they do multiple deployments per second. Okay? You don't get to that without automation and without microservices. Now, the goal may not be travelers, we still have areas that deploy quarterly. So between multiple by second and quarterly, there's a nice range. And it depends what you want to do. But yes, the number of microservices is going to increase complexity like you have no idea. I mean, don't try to do that with manual process. That would be painful. I mean, anybody else who uses microservices? Okay.
Sorry,
please.
another question. Can you expand on how you can reconcile graceful degradation with a lack of orchestration? So when part of it, if you have a complicated system and part of it goes down, how do you maintain general integrity?
So,
how do you mitigate that without a central governance?
so I will preface what I'm going to say with what I say up there. Those are some thoughts, okay, based on what we do at Travelers and based on our experience. So we definitely do not have the answer on microservices, okay? The challenge is the smarts have to go somewhere. So now you don't have a bus anymore to think. So you have to decentralize the smarts. So now, exactly, so now the smarts have to go into microservices, okay? By the way, my rule of thumb on microservices, the way, when I know I have a microservice, remember, were you in a talk when someone, I think from GE, mentioned, it was a 12-factor talk, treat your servers as cattle, not pets. It's the same idea, okay? I know when I have a microservice, when I don't have the temptation to change it. I want something new to happen to it, I just kill it, bring a new one, okay? Which means that basically they have to do only one thing, but they have to do it smartly. Okay. I personally think that this is a research area. I don't think anybody has the answer yet. Okay. Perhaps there are some people at Facebook and, well, of course, Netflix. Netflix was where most things were created. Netflix, Facebook, and Amazon who have the answer, but they are not talking right now. They will eventually. But it really creates, this is really a field of large quantities of objects. And I don't know that we know. It's a little bit of the same problem as IoT. Okay, please.
Yeah. So I think there's two things here. One is the difference between incidental complexity and essential complexity.
Yeah.
I think it's been discussed by a few times already in the 70s and 80s. There's this beautiful article called No Silver Bullet that talks about that none of these developments, and of course this was a decade before microservices, but there were similar ideas that we can solve all our problems by this, and he was talking about, what was his name again? The guy who wrote The Mythical Man Month.
Fred Brooks. Fred Brooks. Oh, yeah.
So he says, new tools or new methodologies can get rid of incidental complexity, or can help manage that, but they can never get rid of essential complexity, or because that's just there. So if you divide your problem up into many small services, then the complexity will actually be in how those interact.
Absolutely.
And the other thing I wanted to say is that the microservices idea is, I think, is about dealing with dependencies, right? That's why you need the robustness to make things less dependent on each other. So in my talk earlier this morning, I talked also about dealing with dependencies.
You did.
By putting time as part of your architecture work, with introducing the time and doing a dependency analysis. Microservices can get rid of technical dependencies, but they can never get rid of logical dependencies. Logical dependency will always be there because if a piece of information is not present in the landscape of microservices, you will never be able to give it to the user.
Absolutely. I agree.
You will always depend on that information being somewhere in the system. So the logical dependencies, still, even if you have microservices, you still need to take them into account and to use them in your roadmap.
Yeah, I agree. Totally agree. So definitely, this is one area where will come a lot of feedback because you're right. We don't know. By the way, how many people have read? You actually gave me a good point. How many people have read Fred Brooks' book? Of course, that's Mythical Man Month. If you haven't, please get a copy. Okay, that book was written. Fred Brooks was the guy who ran the development effort for US 360, which was written in the 60s by definition. Okay, and there's one chapter on hardware that shows you how dated the book is. Every other chapter is amazingly up to date. It's almost, it's as if he really came from the future. I mean, when he wrote that book, it's amazing. And we don't learn. That's the other thing. We have all these things. This is exactly like coupling. We don't learn. Okay? We basically see those things. We say, yeah, good idea. We do not learn. So anyway.
So, to
Sure,
summarize
please.
what you were saying, if we were, let's say we're making a rocket, and we
Yes.
need to make a guidance system. So, we could use some of these methods, and we could simplify the process of making this guidance system that goes in this rocket, and maybe reduce the time it takes to do that, and lower the expenses. But that still doesn't make the moon any closer.
No.
So that's kind of
That
the
is
end result is still what it is.
exactly. Oh, yeah.
Make our
The moon doesn't move. Well, it
Make it
does
less
move, but
painful.
it doesn't, the target doesn't move. Absolutely.
Make it less painful to get.
Absolutely. Oh, absolutely. The goal is, it's very much to try to think a little bit differently over the problem. That's always. Okay, so that was microservices. Goodbye, kittens. So now, okay, so how would you do that one? Basically, so now let's assume that we want to do some changes to this, okay? And how do we actually start migrating an architecture to some smaller components? I'm going to give you an answer quickly. Okay, so of course, going to put some new services in place, and that's obvious, right? I just finished talking about microservices, so it's obvious. The answer to the question is microservices or mini-services. But there's something else at play that I absolutely want you to think about. This DBMS here, okay, assume that this is a SQL server or a SQL type of database, some kind, okay? If you're going to use, for example, Oracle, you're going to pay some good money for some proprietary extensions. Goodness, so you're going to use them. I mean, if you pay for them, you're going to use them. Well, here's the problem. Now you're locked in Oracle. Okay, so this is another case of tight coupling. Also, this happened to me a few years back. Basically, we're designing one of those policy admin systems. And policy admin systems really work based on documents. I mean, an insurance policy is a document. So the best representation of the object is a document. Only one problem, we didn't have a document database at the time. We had Oracle, so we did what we thought was the next best thing. We couldn't get the XML function of Oracle to work, so we just put everything in a blob and show it in a blob. Well, which is nice. So now, a few years back, a few years forward, now we have document databases. We use MongoDB quite often. Here's the problem. Who is going to pay for retrofitting, basically, MongoDB into the design? Answer, nobody. Go and try to sell your business users on doing that. Good luck with that. Okay? So this is where principle 4 configure a little bit of principle 3. This is one case where you have to look a little bit ahead and say, hey, you know what? Isolate things that may change. Okay? Beware of basically vendor promises because they're not always fulfilled. So architecting is a lot also of kind of expecting the unexpected. Maybe. Okay, so 5, this is, I like 5 a lot because this is when people get very uncomfortable. 5 is really about, at the end of the day, okay, if we have, and this shows a little bit of an agile thing, at the end of the day, if we're only going to architect for the build, okay, that's not going to be enough. You really got to think beyond the build. You really got to think about how do I facilitate the testing. Testing is a very important thing, okay? And the move to production and the fact, basically production support. Architects need to look at the whole thing, okay? So if you really look at this, okay, you have some couple of techniques that can be leveraged, okay? You can design small, even microservices, or as small as possible, API testable. That's a very important concept, okay? If your service is not API testable, what's going to happen is you're going to have to wait until they are all delivered to start testing. Not a good idea. You want to deliver and test incrementally. One of the secrets. Okay. You also don't want another thing we learn, and this kind of thing you can only learn by doing. Another thing we learn is every piece of software generated by integration needs to be tested very quickly and accepted very quickly. You don't want typically to wait too long, but the time the software is basically delivered by a developer or a pair of developers, we get over that, and the time basically it's tested. Because developers forget. If you basically test something a month after it has been coded, I don't know, sure there's a bug, but I don't know what they did at the time. Okay? So definitely keep that in mind. Speed is important. Okay. Service virtualization, of course, that's a very useful technique. How many people actually use service virtualization? No? No? How many people have mainframes? Nobody? Right. So service virtualization allows you to actually test things without having a mainframe, which is nice, because if you're banking on a mainframe, well, time on a mainframe is difficult to get. Okay, so that's a nice thing to have. There are other techniques as well. One thing I really like personally is the concept of test-driven development, because the more tests you do up front, the less tests you have to do after. Okay, and especially coupled with pairing, your QA becomes very slim, which is nice. Again, another way to speed things up. Any other techniques you guys use to make sure that things are tested easily and are kept in production? I'd love to hear that. Small batches, of course, is one. Anything else? Okay. So, the one before last, okay? How do we optimize software delivery? So what you see up there is basically a typical situation where people have adopted some kind of agile method. See, let's say SAFe. Okay, I can talk about that because we use SAFe at Travelers. So they use SAFe, okay? But what they really haven't changed beyond SAFe the way they test and deliver software. Okay, so even if you feel very good because we are agile, what are you talking about? Okay, well, the whole thing is really very far for continuous delivery. And the problem happens in what I call the last mile, which is testing and move to production. You always have this syndrome where you get to the production people, and at Travelers we have a process called EIOC. Steve, Chris, you remember what EIOC stands for? Anyway, so it's a gate. It's a gate. And this is where basically you come in with your system, this wonderful system I expect to put it in production next week. And they look at you and say, you expect what exactly? And you have a checklist. You failed this, come back when you're ready. Say, well, I don't want to hear it, doesn't go to production. We want to avoid that. That's kind of the gate syndrome. Okay? So the idea is really to try to integrate as much as we can. So in this case, what my team did, they use a concept on containers, which you guys know about, of course. Now, this slide, I should have a beware on that slide. This slide is extremely, extremely simplified. Okay? It doesn't talk, for example, a container management system, which do not do containers with a container management system. This is like a disclaimer, okay? Because you'll get into really hard things, especially if you do microservices at the same time. But the idea is really you package the app and its dependencies as much as you can, and it's not perfect yet, into a container, and you just move the container. Kind of the image of the container on a ship that we were shown yesterday. I wish life was that simple. But it actually works. There are other techniques to do that. And again, I mean, if you look at companies like Amazon or Netflix, their secret is simple. Think small. Again, small batches. Don't try to basically fill those containers too much. Anybody using containers? Nobody? Docker, come on. Somebody must be using Docker. Yes, yeah. Please. So
we have several teams that are deploying using Docker.
Yeah.
And then we have other teams that are not ready to do that.
Yeah. So at Travelers, what we do, we use the Pureur cloud. And so our containers are managed by Pureur cloud. So we use Docker within Pureur cloud. Definitely. So I didn't want to get into too much cloud, but and we only use it internally. We are not able yet, for totally different reasons, for legal reasons and IP reasons, we're not able to send things in the public cloud. But what we found out is containers are very useful, but as part of a bigger thing. But they do work. I mean, you can actually package your apps, and especially if you're going to do microservices, very useful. Anybody else? Okay. How are we doing on time? Ooh. If I want to get to my Gordos, I'm going to have to speed up a little bit. Okay, that one, we don't have to spend a lot of time on 6, because you guys know that, right? This is Conway's law, and that has, I know. Anybody that doesn't know Conway's law? Right, okay. But this is what I was explaining at the beginning of this talk. Architecture is much more than just technology. You have to think organization, think communication, think all this. Okay? If you don't organize your groups in an efficient way, then your design is going to suffer. That's simple. Okay? So let's say you have something like this. How many people can relate to this? Yes. Okay, so you have basically some solution architects. I didn't even show the enterprise architects because I run out of space. You have some DBAs. Everybody has DBAs, right? You have, on the development, you have some designers. Well, we need designers. You have some UI people who are probably agile. You have some service people who are iterative. And you have some backend specialists, which are more waterfall. Then you got some testers, and the testers like the gate. Okay, you shall test with us before you move to production. And then if you didn't get that message, you have DevOps people that basically, and the production people say, no, don't move past us. You shall not move past us. So try to deliver basically a system with that organization, and what's going to happen, you're going to have a lot of communication issues. So the idea is reorganize along capabilities. Okay, and this is going to give you a lot of benefits. I'm serious about that, a lot of benefits. The first benefit is people are going to feel much better because now they see the fruit of their labors. Now they actually work on something end-to-end and instant. This is the reason why in Agile they talk about full-stack developers. That's why. Okay? So that's one. Especially if you couple that with pairing. I'm a big believer in pairing. Okay? And we don't just pair developers, we pair everybody. Pairing give you two things, at least two things. One, actually three things, okay? One is it actually removes redundancy because if someone goes as a problem, say medical emergency or something like this, you always have someone, it's a spare wheel, but surely, okay? The second thing, you train people by pairing, and we rotate pairs often. You actually train people, okay? And the third thing is think of a cockpit of a plane. We all flew to get here, right? Okay, pilot, co-pilot. What do you think that is? Well, it's QA. Okay, so you actually build your QA inside, which is great. Chris, you want to say, because Chris has been pairing for.
Yes, I'll just talk briefly about this. So we actually had the opportunity to create a team like this for the CEO project that Pierre mentioned. And one of the nice things was you start to understand the language of the people around you. You know, you sit with the back-end folks who you haven't worked with before and you understand how they think about the system, how they talk about the system. And then when you have a problem when you're working on the front end, you can talk to them in their language and how they understand the system. And so it's no longer, I don't understand what you're talking about. Let's figure this out. Let's have a 2-hour meeting to talk about it. It's, hey, here's this issue. I think it's this part of the code. You figure it out in 10 minutes or so, and you move on from there. So it's really about the common language and the camaraderie. And the second piece is when you organize in capabilities, there's that a product ownership aspect that Pierre mentioned. You start to feel ownership of the product yourself. You're not delivering things and just saying, oh, I'm just going to hand this over to QA. They'll worry about it. And if there's something wrong, they'll let me know about it. It's, no, I feel like I own this. I want to deliver something that I care about, and that is quality. So I think that's the important piece of this.
Thank you, Chris.
For large organizations, I understand, but for mid-size to small, how practical is it? Now you multiplied your resources into.
Oh, no. So I'm sorry. You're excellent. Those are roles. Okay, those are roles. Those are roles. You don't need. This doesn't match one-to-one people. People can play multiple roles. But also, what this generates as well, which is, thank you for actually asking a question because you made a very good point. The role of the architect disappears. What happens is you don't have a person anymore that is called an architect with a badge. The actual function of the architect can be played by someone else. So what you have is those are basically functions that they played, but you could have actually 1 or 2 people or 3 or 4 in each group. The important thing is they actually learn a lot. And now, instead of having the specialist that only does one thing and one thing only, you now have people who can actually do multiple things, which is a very powerful thing. Sorry.
Did you have to change the reporting structure?
Yes.
To do this for it?
Yes. You got to change. This is going way slow, right? You got to change the way you basically organize your teams. Absolutely.
So what did that look like?
Although what you can do is something we used to do when I was in consulting. I was in consulting for about 10 years. And in consulting, you basically have 2, and you can relate to that, You have two organizations. You have the formal organization, the group you are part of for admin purposes. And then when you're on your project, you basically have the project organization, which is different. Okay? So think of this, if you don't want to change the organization too quickly, think of this as a project organization. So you basically have 3 projects, quote, order and fulfill. And people are temporarily gotten out of their standard organization into a new organization temporarily, and then when it's done, they go back. The thing is, they're probably not going to go back, but they don't need to do that. I'm sorry. I'll get to you.
One problem that I commonly see with this approach is that the balancing of supply and demand from a capacity standpoint tends to get in the way of this, because you may have quote be, the first quarter be really high in terms of what needs to be done, but in the next quarter, there may be no work at all for quote and tons of work for order.
Yeah.
So how do you manage the ownership while also being able to respond to where the demand is?
And that's a training part of it. That's the beauty of pairing, is that you can actually retrain people very quickly. And basically, so you can actually take someone who was working on code, and you're right, code, we're done. We're going to redeploy people on order. Okay? You can actually retrain them very quickly. People gather really knowledge about what they work on very quickly. It's almost, I don't want to make it sound better than it is, but it's really, really, really very effective.
And maybe a follow-on is if you can move people around that easily, then aren't you moving back to more of a project-based approach because you're moving people based off of what needs to be done today instead of long-term ownership?
Yes, absolutely. I mean, to me, product is really an umbrella of a project. Okay, so you're here attached a project to product. The concept of product is to basically force people to think longer on a project. But the project concept still exists. I just don't have project managers anymore.
Back to something we talked about earlier was the role of the product.
Yes.
Owner, product manager, depending on your lexicon. So the role of designer I see on the team is, maybe more, is corporate serve that kind of role? Where do you see product in this as well? Do you see product, everyone is product, as you said, many people can fill the role of architect, many people can fill the role of DBA. Because of the scarcity of resources that was pointed out, do you feel the same about product and that role?
So to me, at least to me, you only have one product manager for product. Okay, so product sits a little bit on top of that. Like you don't decentralize product management unless you really get. I mean, if you need more, if you get to a very large product, you're going to need more product managers. But the products I've been associated with so far, I got away with one product manager. But that's again, this is based on what we did.
So I'm curious why that is, why that applies to product and not to, say, architects or DBAs. Why do you not get away with one architect? Why do you not get away with one designer?
Because basically, I think my answer to that is you really need to constantly have access to the architect. So having the architect immerse into the role of the architecture, I don't even know, on UMU, I don't even know that we have anybody who is actually called an architect.
Yeah, so typically we didn't actually have a role of an architect. We would just, everybody swivel around, talk about the major design decision that had to occur, and then weigh the pros and cons and make a decision to move forward. So it was like architecture by team, basically.
Yeah, exactly. So it's I know we're pushing a concept because this is supposed to be an architecture conference, right? But yeah, I'm sorry. Okay, what about you?
So to get to this kind of architecture,
Yes.
you have to increase the team size.
No. So this is actually one of the big fallacies of pairing. People, your management is first going to look at you. Now I have 2 people to do the work of 1. Show me how that's going to save money. It does. Because what you do is you displace the work from the whole testing work is up front. So if you look at this, okay, my testing team is actually quite large today. Very large teams. Okay, in this, we don't have a testing team anymore. The testing team is basically immersed. Okay, we get to a point where the PM does the QA testing. It's very quick because testing is embedded in the whole thing.
So it's a process of leveraging skills of the whole process from beginning to end.
Mm-hmm.
Can you go to the other slide there?
The first one, this one?
Yeah, so the architects, and so, well, probably, I can visualize more at the development area, developers, the organization where I am now, they just write their code and they think they're done. And then the testing group, waits until they're finished. But it's a matter of integrating that to where as you're developing with the testing in mind.
And the deployment in mind.
Forward, so
Exactly.
that they end up, the integration and communication between that.
Exactly. You got it.
Leads to that
Yeah.
other illustration, which is the columns like all these people, but they're underneath.
Exactly. And the beauty of this is basically everybody owns the architecture. Everybody owns the testing. I mean, it's basically you get people who, as opposed to a bunch of specialists that, all I'm going to do is this, and catch it, Chris. No, you get people who own the process end to end. It's really quite, yes.
Did you ever find with this kind of organizational structure that you had interdependencies between business capabilities that needed to be coordinated in order to schedule releases? You come across problems with that? Because I noticed there was a large coordination effort when you had dependencies between.
Yes, and that's why, now you get into safe, right? This was safe, release train, was supposed to coordinate. We haven't reached, so on those projects, we haven't reached that point yet. Like I can see that we're going to reach a point where we need to coordinate, yes. We haven't reached that point. So you think about the Amazon example, right? Multiple releases per second. Somehow, I think the whole key is to release by very small batches. If you release by small batches, your coordination doesn't go away, but it's a lesser issue. Why, if you have big batches, this is when you get into a big issue of coordination.
Yeah, which is inevitable, right?
Yes.
Otherwise, it wouldn't.
Exactly. Yes.
But you do end up with dependencies between
Absolutely.
scheduling stuff.
Anybody else?
A comment regarding that. Our organization for a long time had been the structure that you're advocating going towards.
Right.
And then we changed the organization to somewhat look like this.
Mm-hmm.
And then we went back. And I'll tell you the both sides of the story
Sure.
very shortly.
Of course.
When we were like that, we used to make sure that our dependencies with the other verticals, towers, microservices, mega services, whatever you want to contain it with, that our interaction between those two different functional areas are minimal, clear, crisp, and well-defined. And then based on those communication, we used to communicate with each other, we used to create structures, and we used to work. We changed to this, and all started commingling and working because everybody was thinking in all directions at all the time.
Mm-hmm.
And now we are changing back.
Back to
and
this?
now we are, from this we are changing back to what you are advocating.
Okay. To this.
And now again we are thinking of this one. And
Yeah.
now again we are thinking of clear, crisp communication and pathways and interfaces between the teams, the modules, and the work.
Right.
That's the advantage that I have seen over the period
Yep.
of last
Makes
10
sense.
years.
Yeah, makes sense. And again, this is work in progress, okay? Believe me, I said at the start, I do not have the answer. I do not have any of the answers, but all I can share is what we have done. We're getting a little bit out of time soon. I just would like, so we're going to skip that case study, which was a very strangler pattern. So just wanted to leave you with this, okay? Which is basically, the reason why this has worked for us is really that it brings some discipline to the agile projects, absolutely. I mean, that's normal. But also, really, this is driven by feedback, which is what we value most. So to your point, I mean, the idea is, so key to change organizations often because you get the feedback. It tells me is you actually people react. I think there's only one way to go wrong with those things is basically never to change. Because if you don't change, then what's going to happen is start fossilized. You basically start getting very rigid and not being able to react to change anymore. So that will leave you with that. The idea is really to, again, we don't think of it as a formal methodology. This is all some principles, some toolbox, and put the two together in a context and see what happens. Okay. Thank you, everyone. Thank you so much.